This video is about how to run reliability analysis in SPSS. The data we are going to look at is the personality data, which measures the big 5 personality traits. These are the sample items for 2 of the personality traits. You can see that some of the items have the asterisks, and so that means the item is not awarded at the same direction as the other items. So these are items that need to be recoded. In the previous video, I have recoded these items. And recoding is important for reliability analysis because Cronbach alpha is the average of possible split half correlations. In this video, we're going to run a reliability analysis. I'm going to use these items for the measure actual version. So to run on Cronbach alpha, we're going to go to Analyze and then Scale Reliability Analysis. So we're going to put these items that measure actual version in the item box. So which is the question 2, question 7. Question 12 is a recoded item. So I have this little r here, yes. And then question 17, which is here. And then question 22. And question 27, which is a recoded item. So make sure I have this correct here. And then by default, Cronbach alpha will be used for a reliability analysis. And you can label the scale as, I'll give a name. So for ours, this is the actual version. In the statistic here, I'm going to check item, scale if item deleted. So that we'll get the descriptives. And then for the here, I'm going to check inter-item correlations. Try this just correlation matrix for these items. And then the summaries here, I'm going to also check a correlation, which give a summary measure of the correlation. Then go to continue and OK. So in the output here, we can see that we have some missing data. So the 178 responses will be used for the reliability analysis. So this is the reliability statistic from Cronbach's alpha. There's 6 items, and we can see that the Cronbach alpha value is 0.704, which is just about the threshold. Because for Cronbach alpha, we want the alpha value to be 0.7 or above. And so that's a good index for internal consistency reliability. And the other one is the Cronbach alpha based on standardized items. And this is if you have items that's not measured on the same scale. Since our items are measured on using same Likert scale, we don't really need to use this. We can just report the Cronbach alpha here. And the table here is the item statistics. So to report the mean standard deviation for each of the 6 items. Just by looking at these, yeah, so because this is the Likert scale from 1 to 5, it looks like they all kind of above 3. And the question 7 seems to have the highest mean. And this one has more dispersion than compared with others, which is the recoded item. One of the recoded items, I should say. And then this one is the correlation matrix. So you can look at each of the item to see how the item correlate with the other items. So for question 2, it looks like does not correlate that well with question 7. And then this is question 7. Question 7 seem to have quite a low values for seem to be the rest of the items. And question 12, there's one is low and the other, yeah. So this is actually the question 7. And then question 17 seems to be all above point, 25. And question 22, there's a low correlation, which is the same item, which is question 7. And this is for question 27, it has a correlated low with question 7. So just by looking at the correlation matrix, it seems question 7 does not correlate well with the other items. And then if we go to this one, yeah, so this is the summary statistic for correlation. So to give the average correlation and the minimum correlation in the correlation matrix and the maximum. So this is the average of the correlation individual, this is item inter-item correlation. Yeah. And usually we want the correlation to be like close to 0.3. Yeah, so 0.3 is like a moderate size. Yeah, so and the next table is the item total statistics, which is also used for table to look at. So we're looking at this corrected item total correlation, which is the correlation between the item and and then the rest of the items, the sum of the rest of the items. Yeah. So that's called item total, and corrected because the total is not including the item itself. So we want this correlation to be high, like 0.3 or above. We can see that there's one correlation seem to be low. That's the question 7. So it tells that question 7 seem to be not correlated well with the other items, which kind of confirms with what we saw in the inter-item correlation matrix. And this column is the squared multiple correlation. So basically is the individual item, how they correlated with the rest of the items, and then squared. So it's a variance. Yeah, so it's kind of tell the shared variance between the item and the other items. Again, lower value means that that item does not correlate well with the other item. So it kind of confirms this. And then the last column is the Cronbach alpha if the item deleted. So we know that for the 6 items, yeah, we look the reliability value, yeah, the Cronbach alpha for the 6 items is 0.704. So if we go back here, this one tells us if this item removed, the Cronbach alpha value would be what value. So if we remove question 2, our alpha will be actually so will reduced. So it's not a good idea to remove question 2 because question 2 seems to be goes well with the other items. Then if you're looking at this question 7, so if we remove question 7, the alpha value can will be up. We are up a bit. Yeah, so it will be better. Then so it looks like it's statistically it might be good, makes sense to remove question 7. And so that's also because question 7 does not seem to correlate well with the rest of items. So if we remove it, we can get a higher Cronbach alpha. And so, but in terms of whether you need to remove question 7, you also want to look at based on whether the item is a good measure of actual version. So that is basically not only you look at statistics, but also you look at based on judgment whether it's a good item to keep in. So this is the video about running the reliability analysis in SPSS. Thanks for watching.